Okay, hello friends. Let us take one example of a triple integration. So see that here they have asked us to evaluate a triple integration over some value b, dx dy dz x square plus y square plus z square 3 by 2 raised to 3 by 2, where v is annulus between spheres x square plus y square plus z square equal to 4 and x square plus y square plus z square equal to 9. Okay. Uh, Now one thing you should note here, that inside the integration, okay, there are even powers of x square, y square and z square there involved. Another thing, that the v is given as in terms of full spheres. Okay, so it's like an annulus. Annulus is what? So suppose if I draw it here, this is a sphere which is centered at origin and of radius 2. So this is of 2 radius, right? And another sphere is there. Okay, this is again centered at origin but of radius 3. This, and the annulus is this area. So this area is called as, or this region is called as annulus. But now see that I have not drawn it in a 3 dimension. You can just imagine that this is a ball, so it's a sphere, and this is a ball which is covering that sphere. So there are two balls, okay, concentric and having different radii. Okay, so the region between the two balls is called as the annulus. Fine. Okay, so we are doing like this. So see that now. Suppose if I join this as my R. Okay, first of all, I have decided to convert this to the polar form. So I am using the relations x equal to r sine theta cos phi, y is equal to r sine theta sine phi, and z is equal to r cos theta. Okay, this I am going to use, and then dx dy dz will be r square sine theta dr d theta d phi. Okay, now how my r is varying? So I say where, see now this is my r, okay, but I am not interested about this much portion. What I am interested is from this end to this end. So my r is varying from 2 to 3. So 2 less equal r less equal 3. Okay, this is important. And since the annulus is total, so it's like a full sphere now. Okay, my theta will be varying from 0 less equal theta less equal pi, and phi will vary from 0 less equal phi less equal 2. So we have given these limits. So now limits are there, this conversion is there. Okay, so in the conversion we have written, and x square plus y square plus z square, it will be what? Now it is r square. With this, okay, you have this relation now. Okay, let us take everything inside the integration. Therefore, I say the integration is equal to a triple integration. Okay, dx dy dz now replaced by what? R square sine theta dr d theta d phi divided by, now see that this becomes r square, so it is r cube, because r square raised to 3 by 2, so that 2 get cancelled and we get r cube. Okay, so and the limits, so inside limit we will put always with respect to r, so I'll put it as or shall we take with respect to theta? Okay, so let's decide that inside limit is always with respect to r, then it is from 2 to 3, then theta from 0 to pi, and then phi from 0 to 2 pi. So we will decide this r theta phi. Okay, so now it is equal to, so 0 to 2 pi I keep as it is. This will be 1 by r, 0 to pi. So 1 by r with respect to dr, so that will be log r from 2 to 3 sin theta d theta d phi, right? Okay, so this is log 3 minus log 2 that I can take outside. So it's a constant quantity, okay, or log 3 by 2 you can write. Integral 0 to 2 pi, integral 0 to pi. Now with respect to sin theta we will evaluate. So d theta, so it will be minus cos theta d phi, and this is varying from 0 to pi. Is that okay? See, this is sin theta d theta. Now this integration, second integration is with respect to theta. So sin theta's integration is minus cos theta. Okay, so this I am writing as log of 3 by 2. Okay, integral 0 to 2 pi. Now what is this? After putting this integration, so I will keep minus outside, and it's cos phi is minus 1, minus cos 0 is 1, d phi. Okay, so this is 2, so that 2 is also coming out. So 2 log of 3 by 2, and then this integration of d phi will be just phi. It is from 0 to 2 pi. Okay, so if you calculate this, this is going to be 2 into log of 3 by 2 into 2 pi minus 0, right? So 2 pi minus 0, so I will write this as 4 pi log 3 by 2. So we have solved this integration. This integration, its value is 4 pi log 3 by 2. Got it? How we have converted? So it's very simple. You just keep this in mind that these relations you are going to use. Okay? And the limits. Right? Once you put that, it's a very simple calculation of evaluation of an integral. Fine. We'll take one more example in the next video.